So in this video, I will be going over 3 of the problems from the homework, so make sure you try them first on your own, and then use this video to correct your work, to go through and make sure your work is shown correctly in terms of presentation, and also that you have the correct answer. So starting in 51, all we need to do is find the 2 angles that are formed by these ropes and this beam that's holding this weight. So we need to first come up with variables to represent these, and you can use any variables you like. So if you want to use capital A and capital B, that's fine. You can use alpha and beta. You can use Greek or English letters. But I would say this, when you're finding angles, you should either use capital English letters or lowercase Greek letters. That's the standard. Okay, so next we see that we have 3 sides and no other angles, which means we don't use law of sines, we use law of cosines. So in this particular case, I will use the version that I always use. C squared is equal to A squared plus B squared minus 2AB cosine C. Now, these letters are just the general formula, and then I need to make them specific to my problem. So specifically for my problem, if I'm trying to find angle A, then I would rewrite this so that angle A is the capital letter, and whatever letter is the capital letter, across on the far left is going to be the corresponding lowercase letter. So I want to have A squared pair up with capital A, okay? So then that's going to leave me with B squared plus C squared minus 2, and then these 2 letters right here get repeated, B, C, and then that's times cosine of angle A. So if it helps to put parentheses here so that you remember that cosine is one number right there, and B and C are their own numbers to be plugged in, that may help. So now we're going to replace little a, this would be little a right here, because it's opposite capital A, right? And then this would be little b, because it's opposite capital B. And we didn't call this thing anything, but I'm going to call it capital C, this other angle, which would make 90 little c. So using A, B, and C is a pretty standard, easy thing to do. So little a is going to be 60. Little b is 45. Little c is 90. And then I leave cosine A because I don't know what angle A is. So next what I want to do is I want to subtract 45 and 90 from both sides. So the sum of 45 squared is what I'm trying to say. 45 squared and 90 squared is 10,125. So I'm going to subtract from both sides 10,125, which again is the sum of 45 squared and 90 squared. So 60 squared minus 10,125 is going to give me now negative 6,525 is equal to, and what's left on the right hand side is the negative 2 times 45 times 90. Cosine A. Now, if you're wondering what work you actually need to show, so far the only thing that I've written on the board that you absolutely need to show, other than labeling your diagram with variables, which is important, even if you are provided with a diagram, you need a fully labeled diagram in your work. Okay, your work should always include your work for me, which you turn into me. Whether uploading your textbook homework or taking care of a test work is always going to be including a fully labeled diagram. And that means adding to the diagram variables so that your equations make sense. So other than that, the only other thing that you have to have that I've written so far is this line right here. Okay? This is where I plugged in all the values into the law of cosines. What I've done before is I've written out things that would be helpful for you as you're learning, but you only need to actually show this line right here. Now, as we're going forward, I'm showing lots of work that is unnecessary because you can do it on the calculator. Next, I want to divide both sides by this number right here, and that number, -2 times 45 times 90, is -8100. So divide both sides by -8100. And in this case, you can use a string of equal signs correctly. What's left on the left-hand side is .8055555555, and then on the right-hand side, on the far right, I'm left with cosine of A. This string of equal signs actually has things that are equal. You need to make sure that when you use equal signs, everything that you are connecting is actually equal. Okay, now we take the inverse cosine of this answer right here, and we get that angle A is equal to 36.34 degrees. I'm just looking real quick at the book. The book rounded to the nearest whole angle, probably because of significant digits. Okay, so for significant digits, I would say that A then is 36 degrees because all the other numbers are only to 2 places. Okay, so to find the other angle, angle B, you repeat this entire process again. This time you replace the capital A with capital B, and you use the variation of this formula that has a little b on the left-hand side. But otherwise, the work is identical. You're just going to change the numbers. And the answer is in the back of the book, of course, but I will tell you it anyway. Angle B is 26 degrees when rounded to the nearest whole number. Okay, so that's 51, and next we're going to go to number 55. Okay, so next we're going to do number 55. Number 55 starts at point A. Starting at point A, a ship sails 18.5 kilometers on a bearing of 189 degrees. Okay, so we're going to be taking a path that is a little close to the south. .5 kilometers, and it's 189 degree bearing means that starting at due north and going clockwise, we have 189 degrees like that. Now I've done this a little bit out of scale to make it easier to label my diagram. Okay, then at that point we're going to turn. And next we are going to sail 47.8 kilometers on a bearing of 317. Okay. This is not drawn to scale, but that's okay. 47.8 kilometers. and this bearing is 317 degrees. So we have, here's due north again, and now we are going clockwise. We have 317 degrees. So then the big question is, what is the distance of the ship from point A? So here's the ship right here. I'm going to move number 55 up here. Okay, 55. Here's my ship. And we want to know the distance of the ship from point A. We can call it anything. I'll call it X. And I need to figure out what this angle is right here. Okay, so let's look at a diagram off to the right that might help us. If we have two north-south lines, these two north-south lines are parallel lines cut by a transversal like this. Okay. So this transversal here represents this transversal here, and here are the two north-south lines. So 189 degrees is right here. That's 189 degrees. 189 degrees is made up of 180 and 9. 180 represents from north to south, and then the 9 degrees is that little gap then. I've not drawn this to scale to make it easier to label. What that means is by alternate interior angles, these two angles right here are congruent, which makes this angle right here 9 degrees. Now what is that angle on the diagram right here? The 9-degree angle would be right here. So this right here is a 9-degree angle right in there. So you subtract 317 from 360 and you have 43 degrees. So 43 degrees is left in that circle. So now you have an angle here, and the sum of these two angles means that this angle that you have is 52 degrees. So you have a 9-degree angle and a 43-degree angle, which make a 52-degree angle. So now we're going to use law of cosines because we have side, angle, side. So the work I would show would be this. X squared is equal to 18.5 squared plus 47.8 squared minus 2 times 18.5 times 47.8 times the cosine of 52 degrees. But let me reiterate again. Other than this equation, you must have a fully labeled diagram. Drawing this over here was just to help you see the alternate interior angles. This one is not required, but the fully labeled diagram is always required for these types of problems in addition to the equation. So now you can type all that into the calculator. And this number is approximately 1538. I'm going to take the square root of the number in the calculator, and that x then is approximately 39.22 kilometers. I guess for this problem, since we see 3 significant digits, I should do 39.2 kilometers would be the more appropriate answer there. And that's what the book has, 39.2. Perfect. So here's our last problem, number 61. What we want to do is use law of cosines because we are in the law of cosines section. So even if there is another way to solve it, we are learning law of cosines in 7.3, so I expect you to use law of cosines here. And so what you want to do is see that you have a triangle. All you have to do is connect these two dots, and voila, you have a triangle. Okay, so what we want to do is find the measure theta. And to do that, what we need is we need all three sides of the triangle. And so we can do that by saying what is the distance between the points. So here's the origin, 0, 0. Here's 6, 8. You can either use the distance formula or you can use the Pythagorean theorem. So for the Pythagorean theorem, you would think about this triangle right here. You have a triangle right here that has 6 and 8 as its side lengths. And so that would make this side right here 10, because you have a 3, 4, 5 triangle, right? A Pythagorean triple. So that's how you use Pythagorean theorem for that one. And then same thing here. If you were to drop a perpendicular down, you can see that you have a side length of 4 and a side length of 3. So you have another 3, 4, 5 triangle. So you have a length right here of 5. So that I don't have a cluttered diagram, I'm now going to erase those two triangles, but I wanted you to see how easily I came up with 5 and 10 just by noting the right triangles that are formed on the grid. This is an XY plane, so we're dealing with a typical grid of graph paper. Okay, what about the other side? So to find the length of the other side, you can use the distance formula, where you're going to take the x coordinates and subtract them, the y coordinates and subtract them, square them. This is actually just a form of using Pythagorean theorem again. And so what we end up with is 2 squared plus 5 squared, which is going to be, what, 29? So this is going to be the square root of 29. So now we have 3 side lengths, and then we have 1 missing angle. So what we want to do now is plug this into law of cosines. So remember that the side opposite the unknown angle is the one that goes on the far left. So we have the square root of 29 squared is equal to 5 squared plus 10 squared minus 2 times 5 times 10 times the cosine of theta. Now we're going to subtract 125 from 29, and we get negative 96. And then this is negative 100 cosine theta. Where did I get the negative 100? 2 times 5 times 10. Negative 2 times 5 times 10. Okay, and then that means that you have a 0.96 equal to cosine theta. So you can use your inverse cosine button with 0.96. And you get 16.26 approximately. So theta is 16.26 degrees. And that's